Hello, my name is Jose Rodriguez, Technical Service Instructor. This video explains the 993K wheel loader brake system. Introduction. Shown are the components of the brake system. Components of the service brake system are shown in red and components of the parking brake system are shown in orange. The brake pump, 1, is common to the service brake system and the parking brake system. The brake system components are brake accumulators, 2, parking brake valve, 3, parking brake control, 4, service brake pedals, 5, rear service brakes, 6, parking brake, 7, manifold, 8, service brake valve, 9, front service brakes, 10. Brake pressure taps. The following brake system pressure taps are located on a plate behind the cab. Rear brake accumulator pressure, 1. Front brake accumulator pressure, 2. Rear brake pressure, 3. Front brake pressure, 4. Brake pump discharge pressure, 5. Brake components. Oil from the brake pump, 1. Flows through a high pressure screen, 2. To the inverse shuttle valve, 3. Located near the brake accumulators, 4. At the front of the rear frame. The inverse shuttle valve directs brake pump oil to the brake accumulators. The brake pressure switch, 5, sends a signal to the powertrain ECM if the brake system hydraulic oil pressure decreases below approximately 8,960 kilopascals, 1,300 psi. The brake relief valve, 6, limits brake system pressure to approximately 18,000 kilopascals, 2,610 psi. When the engine is running, the accumulators supply pressurized oil to the tandem brake valve. If the engine stops or the brake pump fails, the accumulators provide a temporary emergency oil supply to provide braking. Brake discharge pressure and accumulator pressure can be checked at the pressure taps, 7, located in front of the brake accumulators. Brake pump. The brake pump, 1, is mounted to the axle oil cooling supply pump, 2, in the center of the pump housing, 3. The brake pump supplies oil to the brake hydraulic system. When pressure in the brake system is less than approximately 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi, a spool in the pressure compensator, 4, blocks the flow of oil to the pump control piston. Spring force acting on the control piston keeps the swash plate at maximum angle for maximum flow. When the brake system pressure increases above approximately 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi, the oil pressure from the pressure compensator moves the control piston against spring force, which decreases the swash plate angle and pump displacement. The amount of oil per pump revolution is decreased to the amount needed to maintain the system pressure at approximately 3,790 more or less 345 kilopascals, 2,000 more or less 50 psi. Service brake control valve. The service brake valve, 1, is located below the right brake pedal, 2. The left and right brake pedals are mechanically connected. This connection allows the service brake valve to be actuated by either brake pedal. The brake valve directs oil to the service brakes. The hydraulically engaged, multiple disc service brakes are located between the planetaries and the differential at each axle. Each brake contains a piston, discs, and plates. When either brake pedal is depressed, pressure oil moves the piston, which compresses the discs against the plates. The friction between the discs and plates causes the wheels to turn slower or to stop. The heat from brake friction is removed by the oil in the differential housing. When the brake pedal is depressed, the brake switch, 3, opens and the engine ECM deactivates the throttle lock. Brake pressure sensor. The rear brake pressure sensor, 1, and the front brake pressure sensor, 2, are located below and to the rear of the service brake valve, 3. The brake pressure sensors send signals to the powertrain ECM indicating the front brake and rear brake application pressure when the service brake pedal is depressed. Service brake valve components. When the brake pedal is released, left view, The oil passages from the accumulators, 1, to the brakes are closed, and the passages from the brakes to the tank, 2, are opened. Oil in the rear brakes, 3, and front brakes, 4, flows through the respective brake spools to the tank. Spring force at the bottom of the lower spool, 5, moves the brake spools up. When the operator depresses either brake pedal, right view, the piston, 6, contacts the upper springs, 7, which moves the 2 brake spools down. The brake spools close the passages to the tank and open the passages from the 2 accumulators. The oil from the rear accumulator flows through the rear brake spool to engage the rear brakes, 8, and to fill the chamber between the lower brake spool and the upper spool, 9. The oil from the front brake accumulator flows through the lower brake spool to engage the front brakes, 10, and to fill the chamber at the bottom of the lower spool. Service brake valve components cont. The pressure at the bottom of the lower brake spool and the force of the spring, 11, move the lower brake spool up against the pressure in the chamber between the upper brake spool and the lower brake spool. The pressure in the chamber between the upper brake spool and the lower brake spool moves the upper brake spool up against the force on the brake pedal. The force at the bottom of each brake spool balances that brake spool against the force at the top of the brake spool. Each brake spool acts as a pressure-reducing valve to limit the pressure in the brakes proportionally to the force at the top of the respective brake spool. Parking brake control valve. The parking brake control valve, 1, is located on top of the rear frame below the cab. The parking brake control valve directs oil flow to the parking brake. When the parking brake control in the cab is pulled out, the parking brake linkage, 2, moves the spool inside the parking brake valve. The spool blocks oil from the accumulator charging valve to the parking brake and allows the oil in the parking brake to flow to the tank. Spring force then engages the parking brake. When the parking brake control is pushed in, the parking brake linkage moves the spool inside the parking brake valve. The spool allows oil to flow to the parking brake. The oil acts against spring force to release the parking brake. The parking brake limit switch, 3, changes states based on the position of the parking brake control in the cab, which informs the powertrain ECM that the parking brake cable has been moved. The parking brake pressure switch, 4, informs the powertrain ECM if the parking brake pressure is low, brake engaged, or high, brake released. Parking brake. The spring engaged, hydraulically released, multiple disc parking brake is bolted to the output transfer gear case. The brake discs are splined to the hub, which turns with the drive shafts. The plates are splined to the parking brake housing, which is held with bolts, 1, that are anchored to the bearing cage, 2. When the parking brake is released, brake system oil acts against the piston, which moves a plate, 3, outward against spring force. With spring force removed, the discs, the hub, and the drive shafts are allowed to rotate. When the parking brake is engaged, brake system oil in the parking brake flows to the tank. Spring force moves the non-rotating plates against the turning discs, which are splined to the hub. The friction between the discs and plates causes the hub to stop. If the brake pump fails or hydraulic oil flow stops, the parking brake can be manually released to move the machine. To release the parking brake, brake release bolts, 4, are installed in the 3 holes, 5. The bolts are tightened, which forces the plate outward against spring force. With spring force removed, the discs, the hub, and the front drive shaft are allowed to rotate. When not in use, the bolts are stored in the location shown in this view. Brake hydraulic system cut-in. This schematic shows the brake system during the cut-in cycle with the surface brakes engaged and the parking brake engaged. When the accumulator oil pressure decreases below 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi, the brake pump, 1, begins to upstroke and the shuttle valve, 2, enters the cut-in mode. In the cut-in mode, the combined force of the accumulator pressure and spring acting on each outer side of the inverse shuttle valve is less than the high pressure in the center of the inverse shuttle valve. The center pressure moves the 2 halves of the inverse shuttle valve outward. This movement allows oil to flow from the brake pump to the accumulators. When the brake pump is connected to the accumulators, 3, 4, The pressure decreases between the inverse shuttle valve and the check valve. Pump oil flows to the accumulators until the accumulator pressure and the pressure at the inverse shuttle valve reach the 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi, cutout pressure. When the cutout pressure is reached, the pump destrokes. By depressing either the right brake pedal, 5, or the left brake pedal, 6, the service brakes, 7, 8, are engaged. The movement of the brake pedal is mechanically transmitted to the service brake valve, 9, which permits oil to flow through the service brake valve to the rear and front service brakes. Brake hydraulic system cut in, cont. If the machine loses power or if the hydraulic pump fails, the service brakes can still be engaged. The pressure in the accumulators permits several applications of the service brakes to stop the machine or slow the machine enough to engage the parking brake. 10. When the right brake pedal is depressed, the stop lamp switch is closed, which illuminates the brake lights. 11. On the back of the machine. Also, when the right brake pedal is depressed, the right-hand brake pedal switch signals the engine ECM to disable the throttle lock function. The engine ECM sends the switch position data over the CAD data link to the powertrain ECM. When the left brake pedal is depressed, a pulse width modulated PWM signal is sent from the left brake pedal position sensor to the powertrain ECM. The ECM processes the signal and sends an output signal to the impeller clutch solenoid, which decreases impeller clutch pressure. As the pedal is depressed farther, oil pressure to the impeller clutch continues to decrease. When the pedal has been depressed approximately 10 degrees, a mechanical linkage from the left brake pedal to the tandem brake valve causes the service brakes to engage. Brake hydraulic system cut out. When the pressure in the accumulators, 1, 2, increases to the cutout pressure of 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi. The combined oil pressure and spring force on the outer ends of the inverse shuttle valve. 3. Overcome the oil pressure on the inside of the inverse shuttle valve. The inverse shuttle valve moves and blocks the flow of oil to the accumulators. When the flow to the accumulators is blocked, the supply pressure increases. The increased pressure causes the brake pump compensator spool to direct oil to the pump control piston and destroke the brake pump. 4. The check valve prevents the high-pressure oil in the passages to the inverse shuttle valve from flowing back to the brake pump. The inverse shuttle valve will remain in the cut-out mode until the pressure in one of the accumulators decreases to the cut-in pressure of 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi. Brake hydraulic system parking brake released. When the pressure in the accumulators increases to the cutout pressure of 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi, the combined oil pressure and spring force on the outer ends of the inverse shuttle valve. 1. Overcome the oil pressure on the inside of the inverse shuttle valve. The inverse shuttle valve moves and blocks the flow of oil to the accumulators. 2. 3. When the flow to the accumulators is blocked, the supply pressure increases. The increased pressure causes the brake pump compensator spool to direct oil to the pump control piston and destroke the brake pump. 4. The check valve prevents the high-pressure oil in the passages to the inverse shuttle valve from flowing back to the brake pump. The inverse shuttle valve will remain in the cut-out mode until the pressure in one of the accumulators decreases to the cut-in pressure of 13,790 more or less 345 kilopascals, 2,000 more or less 50 psi. The end.